So we're doing OCR's paper 2 from June 17, and if we have a look at the grade boundaries, we're aiming for 47 marks for a 5, 31 marks for a 4. Question 1, we've got a tally chart talking about types of tree. We've got missing frequency and a missing tally, and there's 2 marks for completing the table. Here we've got 5, 6, and then the missing tally chart needs to come to 13. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're also asked in part B to complete the bar chart. First thing we need to do is check out frequency. You can see it's not going up in ones, 10, 11, 12, 13, 14, 15. So we'll try twos, 10, 12, 14, 16, 18 and 20. May as well fill the rest in. And then we just need to put these frequencies onto the bar chart. So beech needs to come up to 15. Oak needs to come up to 18. We've got rowan coming up to 6. And other comes up to 13. Just so you know, you must have gaps between the bars and you must have equal width bars to get full marks on this question. For part C, we're told that we've got 60 trees altogether and we want the percentage that is oak trees. If you look back at the table, we've got 18 oak trees out of the 60. There's your first mark. We need to change that into a percentage. So I'm going to use my equivalent fraction knowledge to do that. I know if I half the top and the bottom of this fraction, I get 9 out of 30. I can divide both of these by 3 and get 3 out of 10. And I'm aiming to get out of 100. So if I multiply top and bottom by 10, I get 30 out of 100. And this is my percentage. The minute you've got out of 100, you've got your percentage. So that's 30%. Question 2, we've got some fraction work to do. Now I won't usually work in mixed numbers, but it's quite easy to change this half into quarters. Okay, double the top, double the bottom, 1/2 is 2 quarters. So what we've actually got is 6 2/4 added to 3 quarters. 4 quarters make the whole 1. This comes to 5 quarters. So we've got another whole 1 and an extra quarter. So just to reiterate, this comes to 5 quarters, which is 1 1/4. Added to the 6 gets me 7 1/4. 4/7 of 63. You get your first mark for doing 63 divided by 7. Even if you don't know the answer to that, that's a mark. 63 divided by 7 is 9. And then we're going to take that 9 and multiply by 4. Part B, we're looking to show that 4/5 is bigger than 7/9. There's several ways to do this, but I'm going to use equivalent fractions again. So we're going to start with the 4/5 and the 7/9. And we're going to get a common denominator for both of these. 5 times 9 is 45. So I'm going to change both fractions to 45ths. I multiplied by 9 here. Multiply the top by 9. 4 times 9 is 36. And multiplied by 5 here. Multiply the top by 5. 5 7s are 35. That is usually enough to show that this fraction is bigger than this one. And therefore 4/5 is the bigger fraction. Part C. A fraction which is bigger than 1/5 and smaller than a quarter. But again, we might want to work in fractions with common denominators. If 5 4s are 20, we can change them both to 20ths. I times by 4, so I'm going to times by 4. I times by 5, so I'm going to times by 5. And when we're looking for a fraction that's bigger than this, but smaller than this, we really want the fraction in between. Now between 4 and 5 is 4.5 20ths. And that's no good as an answer because we can't have a fraction with a decimal in it. So if we take that and double everything, you will get 9 40ths. And that is your final answer. Question 3, we've got someone that's done a calculation, 23 times 12.4, and here's the working that they've done, and we're asked to find the mistake, find the error in the working. And if we look at this first line, 10 times 12.4, they've written 12.4, 12.40 is 12.4, so there's your error. 10 multiplied by 12.4 is actually 124. The rest of the method is fine if we take out this initial error, so I'm just going to work it through. We've got 20 times 12.4 will be double this. 3 times 12.4 is correct. 37.2. And for 23 times 12.4, we need the 248 plus the 37.2. Use a column method to do that. Part B, we've got 4 friends buying cinema tickets. They each pay £6.45. So I'm going to do that calculation first. We've got 4 lots of £6.45. Now what I'm going to do, use my grid method, do 4 lots of 645 pence. I'm going to change that to 645 pence. 4 sixes are 24. Put the 2 zeros on. 4 fours are 16 with the 1 0 on, and 4 fives are 20. If we add these together, 2,400 added to 160 is 2,560. Add the 20 is 2,580. And because in our initial question we had 2 decimal places in the multiplication, we're going to have 2 decimal places in the answer. So altogether they pay £25.80. Now the question is actually how much does a ticket cost? This here is the cost of 3 tickets because the 4th ticket is free. So in order to work out 1 ticket, we're going to take the £25.80 and divide it by 3. Use my bus stop method. 3's into 2 is 0. 3's into 25 is 8. Remainder 1. 3's into 18 is 6. And 3's into 0 is 0. The cost of 1 ticket is £8.60. Question 4. We've got a map with 2 farms on it, A and B. And what's important is the scale. Every 2 centimetres is 1 kilometre. The first part of this question is, use the map to complete the sentences. The distance from A to B is, so we're going to measure that distance. And if you use a ruler, 6.2 centimetres, that gets a mark. If every 2 centimetres is 1 kilometre, then we need to half this to convert to kilometres. So there's your answer for part A. Part B talks about the bearing of B from A, and that key part is from A, meaning we stood at A. Bearings measure from north clockwise using a protractor, and that comes out at 115 degrees. Part B says C is another farm. It is 2.5 kilometers from B on a bearing of 230 degrees. So from B, we're now stood at B. We're going to use a protractor to measure around 230 degrees, which is approximately there. And 2.5 kilometers, well, again, if every kilometer is 2 centimeters, then 2.5 kilometers must be 5 centimeters. So I'm going to draw a line which is 5 centimeters from B. Obviously that's not completely accurate because I haven't got a protractor or a ruler on this device. Set of brackets to expand. We're going to do 3x multiplied by x and 3x multiplied by 2y. Well, 3x times x is 3x squared, and 3x times 2y, 3 times 2 is 6, and it would be positive 6, and x times y is just x, y. You get a mark for each of these. Part B, solving 7x equals 28. Well, if we're timesing by 7, we're going to divide both sides by 7, and we're left with x equals 28 divided by 7 is 4. And part 2 of this question, we've got a slightly more complicated equation to solve. The first step to solving this is to get rid of that take 2 by adding 2 to both sides. And we're left with x over 3 equals, don't forget to do the 9 plus 2, which is 11. And then this is divide by 3, the opposite of that is timesing by 3, and you're left with x equals 33. Question 6 is just about angles. All this information is just explaining the diagram, and I usually find it easy just to work from the diagram. We're being asked about angle XBC, so X to B to C is this angle. We're told it's 65, we just need to explain why. That is called a corresponding angle, and you just need to learn your types of angle for that. Second part of the question is to work out BXC, so BXC, we're looking for this angle. If I quickly sketch the triangle again. So if this base angle is 65, this is an isosceles triangle, then this is also 65. And the reason base angles, isosceles triangle are equal. The angle we're looking for is the third angle in a triangle. We know our triangles add up to 180, so we can do 65, add 65, that comes to 130. Our missing angle is 150, take away 130, sorry 180, take away 130, which is 50 degrees. We would need to say angles in a triangle add to 180 for full marks. Each of these reasons is a mark. The final answer is a mark, showing this 65 is a mark. Question 7, we've got 20 coins in a pot. We've got 1p's, 2p's, 5p's and 10p's, and then it talks about probabilities. Well, the probability is saying 3 out of every 10 coins is a 1 pence. So 3 out of every 10 coins is a 1 pence. There are 20 coins. So if I double the bottom of that fraction and double the top, that is telling me now that 6 out of the 20 are 1p coins. If we do a similar thing to the 2p coins, this is saying 2 out of every 5 is a 2 pence. And if I multiply the bottom by 4 here and multiply the top by 4, that's now saying 8 out of every 20 is a 2 pence. We have got 6 1p's. We've got 8 2p's, and we know altogether there are 20 coins. 6 added to the 8 is 14 coins, which means there are 6 coins left. And we're trying to make 57 pence. If we've got 6 1p's, we've got 6p. If we've got 8 2p's, we've got 16p. 16p at 6p. So we need to make 57 minus 22, 35 pence from these 6 coins. Now I think the nicest way to do that is to have a single 5 pence and 3 10 pences. That's 30p, that's 5p, that's the 35p we need. Don't forget there are 8 2p's and 6 1p's. Question 8, this is asking for the square root of 121. Well, if 11 times 11 is 121, then the square root of 121 is 11. For this question, 4 to the minus 2, well, 4 squared is 16. This negative index puts 1 over the 16. It's not minus 16, it's 1 over 16. Part B, we've got some brackets being squared. If we follow the rules of BIDMAS or BODMAS, we know to do brackets first. And within the brackets, we're going to need to do multiplication first. So we're going to do this 3 times 2, get 9 minus 6 squared. Complete the brackets, 9 minus 6 is 3 squared, and 3 squared is 3 times 3, which is 9. Part C, filling in the missing power, we just need to know that 5 times 5 times 5 is 125. 5 5s are 25, times 5 again is 125, so that's 5 cubed. Question 9, we've got somebody working 7 hours each day for 5 days a week, and she earns £420. And we're trying to work out how much she earns per hour. If you know to take this 420 and divide by 5 and divide by 7, just writing that gets 2 marks. Just knowing to divide down is worth 2 marks. I'm going to do this one step at a time. So I'm going to do 420 divided by 5. I've written my division like this because I'm going to use my equivalent fractions again. If I double top and double bottom, I've got an equivalent calculation. I get 840 divided by 10, which is 84. I then need to take the 84 and divide by 7. So I'm going to use bus stop method for that. 84 divided by 7. How many 7s? Now in 84, 7s into 8 is 1 remainder 1, and 7s into 14 is 2. She earns £12 per hour. Part B, we're told that she's working only 4 days going forwards, and her earnings are to be reduced by 20%, and we're asked to explain whether this 20% is reasonable. Well, we can see we're going from 5 days to 4 days, so we're losing 1 out of 5 days, and 1 out of 5, 1/5, is 20%. Part 2, we're asked to work out how much will Lillian earn for working 4 days a week. We're still working 7 hours for each day, so we've got to do 4 times 7 times 12. So 4 times 7, that's 28. And then we need to multiply by the amount she earns per hour. So I'm going to do 28 multiplied by 12. I'm going to do 10 times 28 is 280. 2 times 28 is 56, we need to add those together. She earns £336. Question 10, we've got a square divided into 3 rectangles, A, B and C. And we're told rectangle A has a length of n centimetres and a width of 2 centimetres. So that's this one. Rectangle C has a length of 4 centimetres. That's this one. And we're asked for an algebraic expression for the width of rectangle C. So what we're actually looking for is this measurement. Well, if the whole measurement is 4 and this part is n from the width of A, then this pink bit must be the whole thing 4 subtract n. The whole thing is 4, take away the n, you're left with this bit. We're asked for an algebraic expression for the area of A. Well, if this is A, we have 2 and n as dimensions. Area is base times height, 2 times n is 2n. Part B says the 3 rectangles have the same area, work out the value of n. So we know the area of this is 2n. I'm going to use rectangle C because we have the measurements of C. This is 4 and this bit is 4 minus n. The area of C will be 4 lots of 4 minus n, base times height again. 4 times 4 is 16 and 4 times negative n is negative 4n. If these two areas are the same, we can write an equation. 2n, the area of A, equals 16 minus 4n, which is the area of C. I need to solve this equation. So I'm going to add 4n to both sides. And we get 6n equals 16. And if 6n equals 16, then n is 16 divided by 6. Divide both sides by 6. I'll use bus stop for that. How many 6's into 16? 6's into 10 is 0. 6's into 16 is 2. With a remainder of 4. 6 into 40 is 6 remainder 4. 6 into 40 is 6 remainder 4. The answer will be 2.66 recurring. Question 11 is given as a Fibonacci sequence. And Fibonacci sequences are the first two terms add together to make the next term. These two terms will add together to make the next term. In order to continue the sequence, we'll need to do 7 add 11, which is 18. And then we'll do 11 add 18, which is 27. In a different Fibonacci sequence, the fourth term is 31 and the fifth term is 50. Now we need the first term. So we've got the first, second, third. We know the fourth term is 31 and the fifth term is 50. And if these two terms add to make this term, then we need to do a subtraction to go the other way. So I'm going to do 50, take away 31 to get this term. 50, take away 31 is 19. I'm going to do 31, take away 19 to get this term. And 31 take away 19 is 12. And 19 take away the 12 will get me the first term. 19 take 12 is 7. Part C, we've got the second and third terms of another Fibonacci sequence, and we've been told that they're x and y, and then we want algebraic expressions for the other terms. Well, these two terms will add together to make this term, so we can just write x add y. These two terms will add together to make the next term, so you can write x add y, or x add 2y is probably better. And then, like in part B, if we're working backwards from a Fibonacci, we need to do this, take away this to get the previous term. So I'm just going to write y minus x. There will be a mark for each of those. So question 12, and we've got a farmer with a field that is a trapezium, and he's also measuring because he wants to find out the area. First part says the farmer has rounded his measurements to two significant figures. Give a reason why he might have done this. And the reason would be just to make finding area easier. We've then got a part B that says the field produces 6,400 kilograms of wheat per hectare, and 1 hectare is 10,000 meters squared. Work out how many kilograms of wheat the field produces. Well, even if I don't know how to complete this question, I'm going to go up here and work out the area of this trapezium. And the area of a trapezium is given by these parallel sides added together. And then we divide that by 2. And we're going to multiply by the perpendicular distance between them. 400 divided by 2. Multiply by 150. 400 divided by 2 is 200. And 200 times 150. 2 times 15 is 30. And then add these 1, 2, 3 zeros on. So the area of the trapezium is 30,000 meters squared. Back to this part of the question, we've got 1 hectare is 10,000 meters squared. So I'm going to take my 30,000 and divide by 10,000, and that will convert the square meters into hectares. Swipe off all these zeros. We've got 3 divided by 1, which is 3 hectares. Final part of the question, we're looking for how many kilograms of wheat. Well, each hectare produces 64,000 kilograms, and we've got 3 hectares, so we're going to do 3 times 64,000. 3 times 60 is 180. 3 times 4 is 12. This comes out at 192. That's the 180 plus the 12. And then 3 zeros on the end. 192,000 kilograms. Question 13, and we've got a front and side elevation of a prism. And it says we've got a pentagon as its cross section, and it's drawn on 1 centimetre square grid. We're looking to draw the plan of the prism, and the plan view will be what it looks like from the top. What I can see is, from the top, I'm going to see a rectangle that's 1 across. So I'm looking at this from the top. And it will be 1, 2, 3, 4, 5, 6 units long. Something like that. And then I'm still looking from the top. And from the top, this slopey bit will just appear flat. So it will only be 3 units across. 1, 2, 3. And then it's still going to be the same width as the prism is. Should look something like that from the top. This bit here is what this slanted bit would look like from straight above, directly above. Second part of the question is to calculate the volume. Well, volume of prism is area of cross section multiplied by the length. So I need this area first. This is the cross section of the prism, and I'm going to go old school on this and just count squares. These two parts will make a full square, and these two parts will make a full square. So the area is 9. And we're going to multiply by the length. 1, 2, 3, 4, 5, 6. 9 sixes or 6 nines of 54. And because this is a volume, we've got centimetres cubed. Question 14, multiplying fractions. You can do this a long way. You can do 2 times 15 is 30 and then work out 15 times 22. But because we've got 15 is a numerator and a denominator, I can literally cancel those out. It's called cross cancelling. And what we're left with is just the 2 over 22, which is 1/11. Question 15, we've got a distance time graph, and this is planning a journey of someone from home to university. Whenever you've got a scale with blank markers on, it's always worth checking what it's going up in. They're usually quite nice, but we'll double check. We've got 9. I'm guessing it's going up in 15 minutes. 9, 9:15, 9:30, 9:45, 10. It is. So this would be 10:30. This here is 11:30. Each little marker is 15 minutes. Up the side of the distance time graph, we can see we're going all the way up to 160 kilometers. So just having a check of the axes of the graph. From the graph journey, we can see distance started down at 0, and right at the end of the journey, the distance is 160 kilometers. So I'm just going to jot that down. Distance is 160 kilometers. Just looking back at the time, we can see we started at 9 o'clock and finished at 11:30. So the time is 2.5 hours. We're looking for average speed, and that's for the whole journey. So we've got those figures that we need. Speed is distance divided by time, which is 160 divided by 2.5. Don't really want to be dividing by decimals, so I'm going to double this top number, double this bottom number, and we get 320 divided by 5. Again, I can make this simpler. If I double top, double bottom, we get 640 divided by 10, and 640 divided by 10 is 64. That is your average speed for the whole journey. Question 16, we've got someone who earned £16,200. She has loan repayments of 6,400, and she's estimating the ratio of her repayments to earnings is 3:8. So we've got repayments is 3 and earnings is 8. We've got to check whether she's correct or not. So we'll just jot those headings down again. We've got repayments to earnings, and she has 6,400 in repayments, 16,200 in earnings, and I'm just going to start simplifying this ratio. Straight away we can swipe off these zeros, just dividing by 10 and dividing by 10 again. We've got 64 to 62 now. We can half both of these because they're even numbers. So we get 32. Half of 160 is 80. So half of 162 is 81. These look quite nice compared to what we're trying to confirm. If I divide both of these by 10, I get 3.2 to 8.1, which is very close to 3.8. Don't forget to answer the question. It says, is she correct? We must say yes. Question 17, we've got some standard algebra to do. This says, rearrange the equation to make x the subject. So what that's saying is we want x on its own. We're going to move everything from this side by doing inverse operations. So firstly, the opposite of taking 3 is adding 3. Do that to both sides. You end up with y plus 3 equals just the 7x. Then we've got 7x, so this is saying 7 times x. The opposite of timesing by 7 is dividing by 7. And we do that to both sides, and what you end up with is y plus 3 over 7 equals x. X is now on its own. X is the subject of the equation. Part B, factorising. We're looking for things that are common to these two terms, or common factors. The only thing that is common in these two terms is the x. So I'm going to take that out as a common factor, open up some brackets, and then say x times something is x squared. X times x is x squared. And then x times something gets me back to minus xy. Well, x times y would be xy. So x times minus y is minus xy. Second bit of factorising in part 2, we've got what's known as a quadratic. Anytime you've got this x squared term, it will normally factorise into two brackets. Firstly, we will always have an x multiplied by an x to get back to x squared. And then we're looking for two numbers that add to make 8, but times to make 12. Start with the numbers that times to make 12. You've got 1 times 12. 2 times 6, and I'm going to stop there because these two numbers times to make 12 but add to make 8, so they go into my bracket, x plus 2 and x plus 6. For question 18, we've got Jenny playing 4 games of golf and her modal score is 76, her mean score is 75. When you've got unknown numbers but you know that the mean is 75, you can pretend first that they're all 75, and what that will do is tell you what they all add up to. So we've got 4 lots of 75, you can add these together. Well, 2 times 75 is 150, so these will come to 300. We're told that the modal score is 76. The modal score is just the mode, so it's saying there's more 76s than any other number. I'll tell you now, those will usually go in the middle of this set of missing numbers. Now we're aiming for a total of 300 from these 4 numbers, and we know we've got at least 2 76s. If we work out what this adds up to, 76 add 76, 70 add 70 is 140, 6 add 6 is 12, 140 add 12 is 152. And we're aiming for 300 from these other 2 numbers. We need 300, take away 52, and we're just going to work this out. I'm going to borrow from there, then we're going to borrow from there. 10 take 2 is 8, 9 take 5 is 4, and 2 take 1 is 1. So we need 148 from these 2 numbers. One of them must be bigger than 76 and one of them must be smaller than 76. So if we need 148, we can half this number. Half of 140 is 70. Half of 8 is 4. So we can say, well, it might be 74 and 74. But then that cancels this mode because I can't have 2 74s and 2 76s. So what we'll do is take 1 from this and get 73 and 75. And what I'm going to do is keep working through this chain of numbers till I get a number higher than 76. And if I keep taking 1 from one side and adding 1 to the other side, I'll settle on 69 and 79. Why have I kept going? Because any of these sets of numbers, except for the 74 and 74, would have solved this problem. But I'm looking at the final part of the question, which says the range is 10. And range is the difference between the biggest and the smallest. And here, the difference between 69 and 79 is 10. So they must be my actual final numbers. Question 19, we've got a ratio of men to children and a ratio of women to children. And we're looking for the ratio of men to women. So I'm going to track these different parts of the ratios using different colours. So we've got men is 11. We've got children is 3. In the second ratio, we've got children is 2. So I'm going to write that here. And then in the second ratio, we've got women is 5. And as long as I get the right numbers under the right labels, I am allowed to swap them around. I'm going to combine these two ratios together to form a single 3-part ratio. Now if we look at this middle zone, we've got children to be 3 parts, children to be 2 parts. If we multiply those together, we can have children being 6 parts. We just need to apply the same multiplication to the entire ratio. So here, that 3 was multiplied by 2 to get 6. I'm going to multiply this 11 by 2, and that would give me 22. On the second ratio, this 2 was multiplied by 3 to get 6. So I'm going to take this 5 and multiply by 3. 5 3s are 15. And what we've got now is a ratio that is men to children to women. I've combined these two separate ratios to create one ratio. So I'll rewrite that up here. Double check the question. We only want actually the ratio of men to women. So I want this and this, which is 22 to 15. Part B of the question, we're told that there are 36 children and we want to find the total population. I'll rewrite the ratio that we just found in part A. If we're told that there are 36 children, we can see how we've gone from 6 to 36 through multiplication. We've multiplied by 6. We just need to multiply each part of this ratio by 6. 6 times 15, 6 tens are 60, 6 fives are 30, 60 add 30 is 90. On this side, 6 twos are 12, 6 20s would be 120. So we're going to need to do 120 add 12, which is 132. And we'll quickly show that using a column method. 6 twos are 12, 6 twos are 12, add this 1, it's 132. Make sure we finish the question. When it says total population, we need to do 132, add 36, add 90. Use my column addition for that. 6 add 2 is 8, 9, 10, 11, 12, 13, 14, 15. And 1 add 1 is 2. Total population is 258. So in this question, we've got a manager of a shoe shop and he samples 50 customers and asks them about one style of shoe that they would buy next. Here are his results. We've got the different types of shoe and how many people said they would buy that type of shoe. George buys 1,000 pairs of shoes with the number of each style based on this survey, these results. And we want to know how many pairs of sandals. If we go to the table, we've got 8 sandals, and that is out of the 50 customers altogether. What we're looking to do is turn this 50 into 1,000. We want to know how many out of 1,000 should be sandals. So I'm going to just write some equivalent fractions. And if we double this, we get out of 100. And then if we times 10, we get out of 1,000. So we'll do the same on the top. Double would be 16. And then times 10 would be 160. You should buy 160 pairs of sandals. It does ask for any assumption that we've made about this sample, and the assumption will always be this data is representative of the whole population. It's like saying that this is a good mix of people. It's not just all one type of person. Final question on this paper, we've got triangles P and Q. They're both right angled, and we're asked to show that the two shorter sides in P, so this and this, have the same length as the two shorter sides in Q, so the same as this and this. If you've got a right angled triangle where you're looking for missing sides only, it's likely to be Pythagoras' theorem. So we've got A, B and C. A and B are the shorter sides, C is the long side, and we write A squared plus B squared equals C squared. We're going to substitute these numbers in. Well, A is what we're looking for, B is 12, and C is 13. Keep working this through. 12 squared, 12 12s are 144. 13 squared, 13 13s are 169. And if we've got something added to 144 is 169, then 169 take away 144 will be A squared. 9 take 4 is 5, 6 take 4 is 2, and 1 take 1 is 0. A squared is 25. A will be the square root of 25, which equals 5. We have just worked out that this missing side, A, is 5, which is the same as the shorter side in Q. Part B says, explain why the two triangles are congruent. Well, we've got a matching side, a matching angle, and another matching side. We've got side, angle, side. That's the end of the paper. Please go back to the front page, check the grade boundaries, check how many marks you've got, see how well you did.